Hey there, welcome to a video discussing worksheet 14, which is called Circuit Training on Derivative of Inverse Functions. I figured I'd make a video to kind of help you get started with this worksheet, which can seem a little confusing at first. And of course, the topic itself is not the easiest, but let's go through it. So the way this starts is that you start with a cell in the top left corner where it says number 1, and you work up a problem. Whatever answer you get, you locate that answer in one of the other cells in this worksheet. You see where it says answer near the top of each cell. So we're going to locate whatever answer we get from number 1, locate it somewhere else in this worksheet, and that will be the second problem we do. We work out that problem, get that answer, locate that answer in one of the other cells, and that'll be the third problem we do. And that's why it's called the circuit training, that if you do everything correctly, you should close the loop of the circuit, hence doing all 14 problems. And of course, if you don't see one of the answers, then that means that you did something wrong. So you have to go through your work. And sometimes that self-discovery can help and be more powerful than someone like me or another person telling you that you did something wrong. When you can discover it for yourself, that's usually a good thing. So that's kind of the method behind the madness here. But let's go over number 1. So f of x is that function, and g of x is the inverse. Find g prime of 5. So what you're going to do is make a little table. I like to put the original on the left, the inverse off to the right. And the input for the inverse is 5. So therefore the output for the original is 5. So, and my original is 2x, 2 parentheses x plus 3, or you can write as 2x plus 6 if you distribute. So if I replace the output with 5 and solve for x, you should get -1 equals 2x, x equals -1/2. So put -1/2 here. Therefore, it is -1/2 right there. Okay. So what this means is that the derivative at -1/2 and the derivative of g, my inverse, at 5 are reciprocals. That's the main concept here for section 4.3 when you're doing derivatives of inverse functions in general. Well, can I find the derivative of -1/2? Sure. What's that prime of x? It's just going to be 2. And guess what? There's no, it's a constant derivative, right? So there's nowhere to plug in for x. The reciprocal, that's 1/2. Therefore, g prime 5 is 1/2. Now I look at 1/2 elsewhere in the worksheet, which is in the top right corner of the second page. This is going to be number 2 as part of our circuit. Again, we have 2 functions that follow this kind of relationship. If you don't recognize what that relationship means, you have a note right above. That means that they're inverses. This is the whole point of this anyway. You might remember from algebra 2 or pre-calc perhaps, but when a composite function equals x, that's going to be indicative that they're inverses of each other. So we have the function for g. So let's call g the original. They'll call f the inverse. And you're asked to plug in 8 into the inverse. So 8 will be the input for the inverse. 8's the output for the original. If 8's the output for the original, 8 equals x cubed. X is going to equal 2. So 2 is the x coordinate that goes with 8 on the original. So the 8, 2 is on the inverse. G prime of 2 and f prime of 8, those are going to be reciprocals of each other. Well, I can find g prime of x. That's going to be 3x squared. I'm going to plug in 2 straight up. That's going to be 12. Okay, I get 12. So then f prime of 8 is going to be 1/12. Now, right below, I do see -1/12. That's a negative, by the way. So don't get confused. 1/12 is really in the lower left corner here. That's going to be number 3. Then you work this one out. And kind of go through the same process again. And so hopefully that gives you a little bit of a head start of what you need to do for this worksheet. If you get stuck, don't worry, we can do it on class on Friday, but I figure this little video kind of gives you a little head start. So good luck.